Hello, everyone. Good afternoon. There are, I believe, 2 different serverless sessions happening right now. So congratulations on picking the right one. Without a shred of bias in there. So yeah, today we're going to talk about crossing the Serverless Fireswamp. If you wanted the other serverless session, then tough. This is the one you got. Hopefully that this will be somewhat educational for everyone in here. Who here has used any of the major functions as a service platform? So Amazon Lambda, Google Cloud Functions, Microsoft Azure Functions. Wow, that's different to when I asked that question 3 years ago. OK, put your hands back up. Everyone keep their hands back up. OK. Keep your hands up if you've used it in production. Oh, actually, like, not that many of you put your hands down. OK, that's great. So we're going to be talking a lot about functions as a service today. We're going to be talking about a little bit more than that as well, but primarily this is a functions as a service talk. So serverless. We skipped a slide there. Serverless. Is it a magical kingdom of unicorns and rainbows? I run a consulting business partly based on serverless, so part of me thinks it's a magical kingdom of unicorns and rainbows. Or is it, in fact, more like a fire swamp of death and destruction and you're going to die? For those of you that have never seen the movie, The Princess Bride, I'm sorry that you're going to not get some of the references in this talk. On the other hand, you win this talk because you get to know about this movie called The Princess Bride, which you can go home and watch because it's fantastic. Serverless can be tricky. It is a new way of building systems, and there are many traps to catch you out on the way. I am still a big fan of it, but there are a few things that you need to know. My one plug, until I get to the end, I co-run a consulting business of two people. We're based here in New York. Most of what we do is Amazon consulting around architecture and operations. We do specialize a lot in serverless when we can. But serverless is not really a be-all and end-all. It often ends up getting mixed up with a lot of other things. And so we do a lot of different types of work on Amazon. And if you're interested about more of what we do, then look up our website. We do consulting and speaking and training and all those wonderful things. OK, let's kick off. Serverless is still pretty new, so I like to level set a little bit at the beginning of all of these talks just to let you know what I think serverless is. Serverless is all about 2 different types of vendor-provided services. The first of these we call back-end as a service, or BaaS. The second of these we call functions as a service, or FaaS. And oftentimes, you use these technologies together. Back-end as a service is all about services like Amazon S3, which I think about as the original serverless service, because it came out 12 years ago, and it's totally serverless. To small vendors like Auth0, who offer user management and password management as a service, to Google Firebase, which is a database that you can connect very, very safely to directly from your mobile clients and your single-page web apps. The interesting thing about all of these things is there are components that are completely developed and managed and operated by somebody else that we integrate with directly from our applications via an API. On the other side of the serverless coin, you have functions as a service, or FaaS. This really became prominent a few years ago when Amazon launched Lambda, which many of you have used. But there are a lot of other things in this world, things like Microsoft Azure Functions, Google Cloud Functions, and a lot of other stuff besides. Functions as a service is all about how you break your application down into individual little functions and then deploy those functions in a very simple way to a platform and let the platform figure out how to actually manage the operations of those components in terms of how to deploy them, how many resources you need, all of that kind of stuff. And we'll be getting into that more in a moment. But it's about how can we break our apps down into very small fine grains of sand so that a vendor platform can look after them for us. So a serverless application is one that makes extensive use of serverless services. And a serverless application might look a little bit like this. So here is a fairly traditional 3-tier-ish web application where we have our single-page web app on the front. I should rename this to progressive web app to be hipster enough on the left-hand side. And our single-page web app is communicating with our API gateway, which is our back-end code, which I'll get onto in a moment. But interestingly, it's also connecting directly to other services. So it's connecting to an authentication service, something like Auth0 or Amazon Cognito. And it's also connecting directly to a database, something like Google Firebase or maybe Amazon DynamoDB. And this is not what we were taught to architect like back in the good old days of the early 2000s and the late 90s. We said, everything shall be kept behind your server. Well, with serverless, we see that very often we are using these applications, these back-end as a service applications directly from our client. Now, that's not to say that we don't write any custom server-side code anymore. We often still do. And in this situation, what we've done is we've taken our server-side code and we've separated them out into two different Lambda functions. So we might have had one app before, but here we've separated them out into two Lambda functions, one to go and buy something and one to go and search for something. But those functions need to be available behind an HTTP interface. So do we run our own Nginx proxy or something like that? No. In this case, we're using an API gateway, and Amazon have an API gateway that they call API gateway, very confusingly. Amazon's API gateway is a serverless service. We don't have to worry about servers and machines and all that kind of stuff. But API gateway is basically HTTPS endpoint and routing as a service. And we tell it how to map URLs to our individual Lambda functions. And it does all of the HTTP-ness for us. So this is an example. Oh, and one other thing to point out. Top right, that's a database. That database might be a serverless database like DynamoDB, or it might be a traditional SQL database, something like Amazon RDS. There's nothing to stop you mixing up serverless and non-serverless technologies within your application and within your architecture, with some caveats that I'll talk about later in the talk. So this is an example of a pretty heftily serverless architecture. So some interesting attributes of serverless services and why they are interesting and useful when I'm developing applications now. So first of all, you have no concern of server nodes or server machines or server processes. That whole idea of individual running servers that have some amount of lifetime that you have to manage goes away entirely. So for example, if you're using something like Amazon S3, how many of you here have used Amazon S3? Quite a few of you. So when you're using Amazon S3, you define a bucket, right? You can store, we'll get onto that in a moment, but when you define a bucket in Amazon S3, you're not defining all of the file server nodes that you want to have in your S3 bucket. You just say, I want a bucket, please, and I want to upload stuff to it. There's no concept when you're dealing with S3 of server machines or server nodes or server processes that from your point of view. The next interesting attribute of serverless services, automatic and invisible auto-scaling based upon usage. So again, with that whole S3 idea, you could store 10 kilobytes in there, or you could store 10 terabytes in there. What Amazon is doing under the covers is completely based upon how you're using it and nothing else. You don't have to specify, I want to have a 10 terabyte bucket. No, the configuration is just the same. And the costs for that go along with it. So you don't always pay for a 10 terabyte bucket. That would be useless. You only pay for a 10 terabyte bucket if you're using it to store 10 terabytes. And similarly with Amazon Lambda, you don't pay for a long-running Lambda instance. You pay for every 100 milliseconds that your function is active. And so this idea of costs based upon very precise usage is prevalent throughout serverless services. And finally, you get this idea of implicit cross-availability zone, HA. So this idea that Amazon will spread your requirements, your applications, and your storage across multiple data centers in the same rough location for every Amazon serverless service, they offer this, and for all the other folks, they offer something similar. So the idea that you get this implicit HA is also useful. Now, I've talked here about Lambda and S3 here as an example. And if you think about these points, they apply the same to back-end as a service and functions as a service, which is why we group them together into this one area of serverless, because they have these similar operational capabilities. We can actually build applications based upon those, and we'll see that again a little bit through the talk. OK, so why would we care about this stuff? There's two main groups of reasons. The first is, if you do it right, this costs less normally for many workloads. And it costs less for two reasons. First of all, there's typically less work for a company to do around operations. This is not no ops. You still have to think about monitoring and logging and all those kinds of parts of ops. But a lot of the low-level operations goes away. You don't have to think about managing operating systems. You don't have to think about managing clusters, all that kind of stuff. That just goes away. So there's less work to do. There's also often typically less infrastructural costs. And this really gets a little bit more into how you're using it. But if you think about a total cost of ownership point of view, you'll find that for many, many workloads, serverless is often cheaper, which is surprising to some people, and it's not universally true. And you can mess it up in ways that I'll show you in the talk. But for many people, they're finding that serverless offers them this total cost of ownership reduction. This is cool. I like this. That's not why I'm interested. I'm interested in this. It's because of the concept to production in hours. So Gregor was talking this morning about how the people up in the penthouse are thinking about speed of change. They're not necessarily thinking about absolutes. This is why I'm interested. How fast can we move? How quickly can we come up with an idea and have that in production? I can have an idea with somebody. I can get a first version of that deployed to production at scale that's completely secure using serverless concepts in less than a day. And this is not hypothetical. This really, really happens. Because so much of that sort of stage zero work that we're used to doing, like going and setting up all of our various clusters and setting up security and blah, 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 this is all done by default for us. Now, many companies will have internal platforms as a service that will help to this regard, but we just get this off the shelf when we start using serverless services that are third party. And this is why I care. I've seen phenomenal changes in how teams work and how teams interact with their product managers because of the kind of versatility this stuff gives them. OK, if you want to know more about what serverless is and why I care and the benefits and drawbacks, I wrote an article about 3 years ago. Don't worry, I updated it last year. And this is on Martin Fowler's website. So if you just search for Martin Fowler and serverless, you will find my article there. It's good, you know, sending you to sleep in the evening reading. All right, let's move on and actually get into the meat of the talk. So there are a bunch of challenges to using serverless. But fortunately, plenty of people have actually faced the Fireswamp and survived. I'm going to talk about some of the thornier concerns and some ways to avoid getting stuck or worse. Mostly, I'm going to be talking about functions as a service. Backend as a service has actually been around a while in some of its phases like S3 and things like PARs that used to exist. But function as a service is a lot newer, and it is also a much more significant change in how we think about building software. And so I'm going to be focusing on functions as a service in this talk. So our first challenge. So we get 10 feet into the Fireswamp, and then we trip over, just as I do over this cord that's right here on the stage. How do we avoid having all of our enthusiasm and gumption removed from us at the very first time that we use Lambda? And of course that wouldn't happen. This is a brand new thing. It's all great, isn't it? So this is a tweet from my friend Sam Newman, who was often speaking at events like this. Sam wrote the O'Reilly book on microservices. He said this about a year ago. He said, the first-time developer experience around AWS Lambda is really bad. Sam's a smart dude. He and I disagree about various things. But overall, he's a smart dude, and he gets things right. If Sam is having a problem with Lambda the first time he uses it, what hope is there for the rest of us? This was his very, very first reaction. But the point being here, the point I want to raise this is it's tricky. This is not how we're used to building software. And the first time you use it is tough. Also, I love AWS, but their UX is not always the best, as those of you who use AWS will know. So how do we get through this? How do we avoid getting stuck right at the beginning? Well, fortunately now, function as a service has been around long enough that there's quite a lot of information out there to help you get started. There are books out there. I'm currently writing a book for O'Reilly that should be out later this year on Lambda. There are tutorials. I've got an 8-part series on using Lambda and Java on my website. But there's communities around this stuff. And so a combination of these things, and so there's like 8 books or so that I know of using this stuff. A combination of using these things and a little bit of persistence as well. And I think as long as you sort of get through that first hour, you're going to find that it's not so bad after all. And it's constantly getting better. And one of the places it's getting better is around frameworks, so sort of lifting the level of abstraction up a little bit. So a bunch of you, those of you that have been around Lambda a while have heard of the Serverless framework, which is an open source tool that's independent of any of the vendors. That was very popular, certainly a couple of years ago, because there really wasn't anything else like it. It was sort of a combined higher level deployment tool along with a plugin architecture. But the rest of the vendors have sort of really been upping their game here. And again, to use Amazon as an example, they have a tool called SAM, the Serverless Application Model, which is both a deployment tool that is mixed in with Amazon's regular deployment tool called CloudFormation, but it's also a bunch of local tooling that you can use to increase your speed of development when you're actually developing Lambda functions. And so there's a lot of stuff changed in this world over the last year or so and continues to be improved. Amazon is spending a fortune in this area right now, really trying to improve the developer experience around serverless applications. So the combination of these things, sort of going out there and reading, getting from the community, as well as using frameworks, is really going to help you get started. OK, now it's time to dig in deep into some thorny technical areas. So the first one I want to talk about of the technical areas are the flame spurts of unmatched scaling. One of the really amazing things about Lambda is that from the very first function that you deploy that one little bit of code. It might be 5 lines of code. It might have only taken you 10 minutes to deploy it. That piece of code will now scale 1,000 instances wide without you doing any work. There's no auto-scaling that you have to manage. There's no configuration switch. That just happens out the box. That's extraordinary. That's one of these benefits of you can put a real app into production in less than a day because we get this amazing auto-scaling story for free that we don't have to manage. It won't just auto-scale out. It will also auto-scale back down. And those of you that are used to managing container clusters know that scaling in is more of the problem than scaling out. And Lambda will just scale in very, very happily. So you have this wonderful scaling thing, which is great. But what happens if you've got this Lambda function, which is scaled 1,000 instances wide, and you wrote it to connect to a SQL database? And you wrote it in the expectation that it would probably only be like 3 or 4 instances hitting that database. And suddenly you've got 1,000 instances hitting that database. What happens to your database? Well, it may well turn into a fiery pit in the floor. And that's unfortunate. And what I mean by that is it might just fail to respond to all the Lambda functions. It's like, oh, OK, fine. Our Lambda app is screwed. Well, the problem is that if you're using a SQL database, it's probably not just the Lambda functions that are talking it. It might be all the other apps that you have talking to it, and suddenly all the other applications that you had talking to it are also having availability problems. So this is a concern. And the reason that this is a concern is because our Lambda has scaled far wider than our database can deal with. And this isn't just about databases. This might be about microservices. You might have your Lambda function talking to a downstream microservice that either can't scale wide, or its auto-scaling might not be fast enough to keep up with the auto-scaling of a Lambda function. It might be other external API services as well. Even Amazon services don't always handle this kind of load. If you're using something like CloudWatch metrics, which is one of the monitoring features available in Amazon, and your Lambda scales 1,000 wide, and you're calling CloudWatch metrics directly from your Lambda function, you will end up losing metrics. It will just happen. So it's a whole bunch of, I could go off on a tangent there, so I won't. But there are a lot of things to think about here where anything that you're calling downstream from your Lambda, what if it doesn't scale? You might have a problem. So how do you solve for this? the first and most obvious solution is where you can use like scaling infrastructure. So try to use other services downstream that will scale in the same kind of way. And what I mean by this is using things like DynamoDB, which is an auto-scaling NoSQL database from Amazon. That will quite happily scale in and out. Try to use vendor services that say that they handle this kind of scaling in and out. CloudWatch Logs, for example, perfectly happy about scaling in and out. It's the CloudWatch metrics that has this problem that I was talking about before. And so you have to really understand the scaling capabilities of all of the downstream services that you're going to talk to. The next option you have is to manage scaling. So one of the features that came out with Lambda about 15 months ago now is that you can actually tell it not to scale that wide. You had no option before this, but as of 15 months ago, you can actually configure your Lambda function to have a maximum concurrency that you want it to go up to. So you might say, only scale this thing 50 wide, only scale this thing 10 wide, only scale this thing 1 wide. Make this a singleton Lambda function. Make this thing scale 0 because you want to turn it off. Like this is what you can do now with Lambda. It's called reserved concurrency because there's this weird aspect to it when you use it that it actually guarantees concurrency available from your overall account, which I'm not going to go into. But this is a tool that you can use if you want to make sure that your Lambda function doesn't scale more than a certain number of instances wide. Now, this may cause problems upstream because it might be that if you have load enough to require 1,000 Lambda functions, if you can only scale it out to 10, you're going to get problems upstream, but at least your downstream services are not going to be impacted from that unexpected load upstream. Another way of thinking about this is to try to be deliberately hybrid. And what I mean by that is embracing the different scaling capabilities of the technologies that you have available to you. So one option here might be that you really, really want to use a SQL database as your backing store, or maybe you have to because that's got a bunch of information in it that's very, very useful. And that SQL database that you're using just can't scale in this way. Maybe that's the situation. So what do? Are you just like screwed? No, you can think about putting components in between your Lambda function and your backend database that can manage that scale for you. So a very common technique here is to use some kind of message queue introduce that between your Lambda function and on your database, so you're spreading out your load over time. You're introducing a buffer here to protect your database. And really, what I mean here by being deliberately hybrid is as opposed to accidentally hybrid. Like, actually think about how you can use the best of all these worlds while understanding that the scaling capabilities of these things are key to building a resilient architecture that's going to work at scale. So those are some ideas to think about how you manage the difference in scaling between Lambda or another functions as a service platform and your downstream services. While I'm talking about scaling and expectations, though, I want to bring up something else around Lambda and scaling and how this can be unexpected. Here's some code. You're not going to be able to read this because it's a big room and this is not very big code. This is 2 different Lambda functions. By the way, this is how you write Lambda, everybody. It's very, very simple. This Lambda function, what it is doing at the beginning, it is going off to another serverless service from Amazon called KMS, Key Management Store. It's basically Amazon's encryption and key as a service. And what it's doing is it's taking an encrypted environment variable and it's decrypting that. So this might be something like a key to access a downstream database or something like that. But at the beginning of when you're processing this Lambda function, it is calling this so it can then do the rest of its work. In that first example, we are calling KMS within the actual Lambda function. In the second example, we've called KMS just slightly outside the Lambda function. What's the difference between these 2 pieces of code? Yep. That's right. What he said. The difference between these 2 pieces of code is at 200 requests a second, it's $19,000 per year. And the cost here is not Lambda, by the way. The cost is KMS. But the reason that this is the case is that you need to know, as this gentleman does, is that with Lambda, you may be getting a new instance of what your code is running in every time your function is called, if your function is only getting called once every 10 minutes or so. But if your function is getting called 200 times a second, Lambda is going to keep these Lambda functions around for 5 or 6 hours. And so you're actually going to be using your function instance possibly 100,000 times for the lifetime of an instance of a Lambda function. Now, you need to know that if you're going to avoid unexpected costs. And that's what I meant at the beginning. Lambda can be extremely cheap if you do it right. But if you don't do it right, and if you don't know some of the nuances of the operations model, you can really kind of shoot yourself in the foot. So again, that was the cost there was from KMS, but KMS is a serverless service that we can use very nicely with another serverless service. Just make sure you do it right, because what you don't want to do is take all that Lambda scaling and set your bank account on fire. Right, let's move on. Next thing I want to talk about is the lightning sand of at least once execution. What do I mean by this? One of my favorite things to use Lambda for is a cron replacement. So you can create a Lambda function. Lambda function can do anything. It's just a program running on a Linux instance. And you can configure your Lambda function so that it's called by a CloudWatch scheduled event, which is Amazon's lingo for just do this on a cron schedule, please. But that Lambda function is running in its own completely isolated world. You just bundle up its dependencies with a Lambda function. You don't have to worry about anything else on the environment. And this is great, because the number of times I've been in a company where there is the one cron server to rule them all, with 250 different cron jobs, with a bunch of environmental dependencies that are all getting up in each other's business, is just, I hate that. It's not what it's awful. Creating a scheduled Lambda task is just one of the easiest things to do. And it's great. And this Lambda task might be doing something like, every day, just run a job against a database, and just calculate something and update some fields or whatever that is. That's great. So let's say we want that to run at 10 o'clock. 10 o'clock comes around, our Lambda function runs. How many times does our Lambda function run? Obviously, it only runs once, doesn't it? Well, it might do. It might run more than once. And one of the things about Lambda, and it's in the documentation, but it's not on the first page of the documentation, is that it guarantees at least once execution for every event. So Lambda is an event-oriented platform. You hook up your Lambda to event sources. So that's tricky. So what if our little job that we're running reads a bunch of stuff from a database, but then writes some stuff to a database? If we call it twice, does that mean that we're going to update that thing twice and then have twice the amount that we wanted before? Oops. So how do we solve this? The first word that you really need to be thinking of, and this is an architecture conference, so it's not scary, is idempotency. Right? We need to be thinking about how we build systems that work in an idempotent way. And what I mean by that is idempotence is all about if you run the same operation with the same input multiple times, it should have exactly the same effect and the exact net side effect as if you just run it once. Right? So in our situation, what we want, in that previous example, what we want to do is build an application that if that Lambda function runs twice, we want the end state of the database to be the same as if it had run only once. And this is idempotency. Now, this is not new. This is not unique to Lambda. This is all about distributed systems. Just like we've been getting used to thinking about the CAP theorem a lot over the last decade, thinking about building idempotent systems is becoming increasingly important as well the more and more we think about building distributed systems. So if you can build idempotency into your solution, that's great. Excuse me. That's the ideal, because then it's just doing the right thing. Everything's going to work efficiently. But sometimes that's tricky. Sometimes that's not possible. It might be that your back-end service maybe is not something that you control. And maybe there is no, you can't rely on whatever service you're calling. Perhaps you're sending SMS text messages to people, And your backend API that you're using to send SMS text messages is just going to repeat if you send it twice. How do you avoid sending the same message twice to some customers? So the way to do this is that you can check for previous processing. Before I get into this, one thing I need to say is that the Lambda will do this rarely. Like, it's one in like tens of thousands of events this is going to happen, by the way. This is not like an every other instance. So it's rare enough that it's very rarely a problem, but it's also rare enough that you're not expecting it. And so it's kind of in that interesting world. So anyway, back to this slide. So what you can do is you can check for previous processing. So one of the things that Lambda does guarantee is that if it does call your Lambda function twice for the same event, it will pass the same unique identifier for both of those requests. There's a thing called an AWS request ID field when Lambda is called. That will be the same if it's the same event that's caused two invocations. You can use that request ID together with some downstream source of atomicity to look to see whether you've already processed this event successfully. One great example here is to use DynamoDB because it has a feature called conditional writes. So if you try and write to a table with this request ID and it's already been written to, the table's already been written to that request ID, that will fail, and so you can use that to know that that Lambda event has already been processed. So this is a way of introducing some amount of transactionality, or at least checking for previous processing when you can't build an idempotent system. All right, let's move on. Oh. Okay. There's an insect. This is because I'm talking about the Fireswamp. That's why I'm getting insects on my lectern. All right. The next one, R.O.U.S's are not rodents of unusual size, not in this world. They are regions of unusual stability. They do exist. 5 of you in the room are going to get that joke. Right. Everyone here who's used Amazon will know that Amazon is broken up into regions. There are currently 20 regions in the world. A region is a fairly closely geographically located set of data centers. In the United States, we have 4 publicly available regions, US East 1, US East 2, which are in North Virginia and Ohio, and US West 1 and US West 2 that are in California and Portland, Oregon, sorry. All the regions work fairly independently. By far, the biggest region in the world is US East 1. Most services that you use, if in doubt, most services that you use are going to end up in US East 1, public services. It's just that it's huge. There's sort of a network effect there, and so lots and lots of people use US East 1. Problem is that US East 1 occasionally goes down. Some of the other regions go down as well, but US East 1 gets lovingly referred to as US Tire Fire 1 occasionally. And the point here is that regions do go down. And Amazon make no guarantee that they're going to have 100% uptime on a region. And so we need to think about what do we do if regions occasionally go down. And I said at the top that Lambda has implicit HA, but it does not have implicit disaster recovery. So how do we think about solving for this? Well, my sort of recommendation here is to think about building multi-region applications. Some people will say, well, because US East 1 might go down, then we need to make sure that we can run all of our stuff on Google or Microsoft. There may be reasons that you want to run stuff on Google and Microsoft, but I'd argue that region instability is not one of them. When US East 1 has gone down, there's never been a problem with all of the other regions. And so building for multi-region is a huge thing here. Netflix have been talking about running multi-region systems for years. They sort of had this great presentation they gave up 4 years ago or so where they talked about how they run triple hot in 3 regions. And if they noticed instability in one Amazon region, they just route everybody to the other 2. And you can have a triple hot scenario, or you can have a hot scenario with serverless, or you can just have a standby region. And the really great thing about serverless is that it charges based upon usage. So you can deploy your Lambda function to all 20 regions in Lambda, right? If it's only running in US East 1, you're only getting charged for US East 1 until you want to move your traffic over to a different region. And so you're not really paying any more to be deployed to multiple regions. Now, there's some work to do if there's state involved, But trying to think about being multi-region is sort of your main way around solving for regions going down. And it's a lot easier to do multi-region now than it used to be. Another thing to think about is embracing edge computing. So I don't know if any of you are in my business partner John Chapin's previous session, but he showed an example of using Lambda at edge. And Lambda at edge is using Lambda functions, but not running in any particular region, but instead running in all the different CDN locations that Amazon have for CloudFront. There are currently 150 or so CDN edge locations. And when you deploy Lambda, a Lambda at edge function, it deploys to all of those. And so, and they're not anything about regions. They're just like, there are these individual points of presence. So if one POP goes down, then you still got your other 145 to go. So you're fairly safe from a geographical outage if you're using Lambda at edge. It's not useful in many scenarios, but in certain scenarios where you want to have a Lambda that's responding to an external HTTPS API request, then Lambda at edge is super interesting. It is really weird when you start building Lambda at edge, sort of regionless computing, because the first time you experience running your code and not knowing what continent it's running on is really disconcerting. I mean, it's one thing not to know what server your code's running on, but not knowing what continent it's running on is just wild. OK, and if you do use either of these techniques, especially the first one, I really recommend trying to embrace chaos engineering as a way of testing this stuff out. Because the thing about regions going down is they happen very, very rarely. And so you're not really going to know whether your multi-region strategy is going to work unless you test it. And so look up what Netflix and the rest of people who are talking about chaos engineering have been doing. And use it. I mean, it's great even if you're using single region, but certainly for this multi-region stuff, I think chaos engineering has a lot going for it. OK, so just when you're enjoying all the lovely warmth of the fire swamp, we need to talk about Lambda's bogey in the room, which is cold starts. Cold starts are an aspect of using Lambda. That is, when a Lambda function first runs in a new execution environment for the first time, so Lambda creates a process where it's going to run your Lambda function, there is an extra piece of overhead. There's some extra latency there, which can be anything from 200 milliseconds up to 15 seconds, depending on what you're doing. Lots of people, the very first time they use Lambda, experience these cold starts and are like, oh my god, how are we ever going to deal with this latency? We can never use Lambda. And then many of those people who start using Lambda at scale in production go, oh, this isn't such a problem after all. And so it has this sort of problem where it feels more of a problem when you start using Lambda than it typically does in production. But it is a concern. And it really, you know, it's always it's like 50% of the time when people come up to me and talk about Lambda, they say, well, what about cold starts? I'm like, OK. So here's what it is about cold starts. And there's a whole article I have on my website about cold starts, but just in brief. First of all, actually analyze what is going on with your application. Look at how long your cold starts are. Look how often you're going to get a cold start. Know what your performance requirements are. When we're building real-time applications, typically we're thinking about how many nines we're needing to satisfy within a certain period of time, right? So, for example, if your application needs to be 300 milliseconds in 4 nines, it might be that how Lambda is going to work for you is absolutely fine without you making any changes at all. And so it's really key to sort of embrace a scientific and analytical head about this stuff, and also understanding what your actual real requirements are for the application in terms of performance. Because you might not have a problem at all, especially if you're writing an asynchronous application. If you do have a problem, then there's a few things to think about. First of all, make smaller artifacts. A big part of large cold start size is often because people are trying to deploy an application which is, 30, 40, 50 megabytes of artifact size. And the pure act of downloading that file, unpacking it, loading it up into your language runtime, possibly just in time compiling it, that can take a long time if you're using a very, very large artifact. And unfortunately, one of the things that we've got used to in this industry is we've really got a bit lazy about dependencies. We just throw all the dependencies in the kitchen sink into our thing, because who cares if we build a 3 gigabyte Docker file, right? It's just going to be downloaded, and then it's going to run for a week, and we don't care. Well, we really do care when we're building something on a much more ephemeral platform. And so being sort of very deliberately aware about building smaller artifacts is important. Thinking about what your individual function is doing, the individual package Lambda function is doing, and not necessarily your whole application. You may build an entire application out of 20 different Lambda functions, but they can all have different packaging availabilities. You can build a separate zip file or jar file or whatever it is you're doing for all of your different Lambda functions, and that may really help. Next thing, use the right tool for the job. I'm a big fan of using the JVM for Lambda, which is a very uncool thing to say. But we've had a lot of success with it. It's how we got started using Lambda. And I think that the JVM is a great choice for Lambda, especially at high throughput scenarios. But let's face it, some of the time, the boot up time of the JVM can really be a problem. If you need to respond to every single request within 200 milliseconds or within 400 milliseconds, the JVM might not be the job. The JVM might certainly not be the job if you're building your Lambda functions using Scala. And I know people that are really effectively using Scala on Lambda, but they're using it in asynchronous scenarios, or they're using it in very, very high throughput scenarios where 1 in 10,000 timing out is not a problem. But that's not always the case. Sometimes you need much greater control of what you're doing. And if that's the case, then use a language runtime that has a smaller footprint at startup. So use something like Go or JavaScript or something like that, where you don't have this large startup time that the JVM has. But don't throw the JVM out immediately. And finally, what you knew before might not be true now. And this is a slide I added for this. I've done this talk a few times, and I added this for this. Lambda obviously is changing all the time. Amazon are updating all this stuff very, very frequently. But there's a huge change happening almost certainly this year that sort of got pre-announced at reInvent, where the big, big problem with cold starts is VPCs. So if you're using VPCs, and I'm not going to go into detail, those who don't know what it is, but this is just an example. VPCs can slow down cold start time from anywhere from a second up to 10 seconds for various reasons. It's probable that that is going away this year, and that VPCs are no longer going to cause issues for cold starts at all. That's a massive change. There have been other changes in the last 3 years of development of Lambda. So the key here is to, just because someone wrote a blog article 2 years ago on something, which may have been me, or somebody else may have written, that might not be true anymore. This stuff is constantly moving. So when you're making a decision about Lambda or not Lambda for this stuff, just make sure that you got the up-to-date information. OK, so that's sort of all of our sort of tactical questions I want to talk about. I want to talk about some generalities just to finish up. How do we avoid a land war in Asia? How do we think about the bigger questions of serverless? So first of all, throw out your old ideas of architectural constraints. So serverless architecturally is a very different beast to what we're used to. Don't, for example, try to put 20 different responsibilities into one Lambda function, right? That's just going to not work out nicely. Don't try to rebuild a monolith in 500 different tightly bound Lambda functions. That's not going to work out nicely either. Try to think about events as being like your new primitive rather than necessarily database records. And think about how you can make functions a translation thing as opposed to a transporting thing. If you want to move data from one place to the other, try and use some of the other services directly that Amazon has. But use Lambda as your translation point between two different services. Next up, be lazy. Grasp the zen of serverless. Serverless is all about doing less work so that we can concentrate on the business problem that our company actually has. What is the actual differentiated problem that our company has? So what I mean by that is don't build or run a component when you can get somebody else to do that for you perfectly adequately, if you can. If you can avoid writing code and use a backend as a service, that's better than writing code very often. FAS, function as a service, Lambda should really, when you really start getting into this stuff, oftentimes becomes the glue between a whole bunch of different applications. Run what you make. So if you don't embrace the tight feedback loops of serverless, you're really missing half the point. I said at the beginning, the benefits of serverless are cost, TCO, and also, even more importantly, getting something new into production quickly. You can only get something new into production quickly if you know how to run it as well as make it. And so that means understanding what serverless deployment looks like, understanding what serverless operations is, as well as how to build a serverless app. And really start sort of embracing those two things. Serverless operations is actually a fun thing to dig into. And finally, experiment, learn, and share. The cost constraints of typical platforms that we've been used to over decades really don't apply anymore. And our creativity is able to flourish in a way that I don't think it is able to on other platforms. So I really recommend that even for those of you that have sort of started getting into this world, that you try something new out, that you reflect on what worked and what didn't work, and that you chat with your coworkers about that and try and think about what new things that you could do that you haven't done before. And if you manage to do that, and if you get it all just right, then hopefully you might just live happily ever after. Thank you very much. So if you want to read more, I've got these slides and a bunch of resources at this link. I'm also going to be doing a Meet the Experts this afternoon at 3:05, I think it is. So come along and chat then. I think we have like 2 minutes for questions, and then I need to get out of the way so the next speaker can come. So does anyone have any questions? No? All right then. Well, thank you very much, everybody.